that we have to prove something, it means that we have to explain why something actually exists. Like if we have to actually explain the existence of something, then that is actually called its proof. Like we actually have to give an example and we have to justify why a certain thing is like something. For example, if we say that we have to tell that why strawberries or oranges or any other great fruit, say mango, they are very sweet, then it means that it would mean that you may say that under root 2 is kind of an irrational number. So if we have to actually say that mangoes are actually sweet, then it means that they might have sugar in it, right? But we have to what if we have to find out this particular thing, that why they have this kind of ingredient in them, then we actually have to find the practical examples to actually write something in the practical format. For example, if we say that we have to justify something, or we have to actually mention the existence of something, or we have to actually tell the reality of something, then it is called to prove something. Like the solution is, suppose if possible under root 2 is rational, like and if you have to actually explain something in a way, then you actually have to assume that the opposite of it first, because in this way, this is actually only the one method. There are a lot of methods to actually prove the existence or the reality of the numbers. Say this is an example of an irrational number in mathematics. But if you say that for example, if I say I want to say why 1 is called 1, then I will not say that 1 can also be written as 0. I just have to denote a certain designation, or I have to denote or specify a certain reality name to it. But in order to prove something, mathematicians have actually used one method where they have actually said that in order to you may say that prove the reality of something, you just have to first assume its non-reality concept. For example, they have said, suppose if possible under root 2 is rational, but we have to prove that it is an irrational number. So that it means that if you know something that is actually kind of a opposite of something. For example, if you say that you have to say where there is nothing, there is 1, or there is positive 1, then obviously the opposite would mean that there is negative 1, or as its entire opposite scenario. But I think in mathematics, if you actually have to prove the reality of something, you just have to assume its opposite reality first. Why? Because it is written that so that it can be written in the form P over Q, where P, because in this way, if we'll start with its opposite version of reality, like if it is said that you have to prove or justify that under root 2 is an irrational number, then you have to first actually see that maybe it could be an rational number as well. It means that you just have to sometimes do reverse engineering to actually prove your point, because I believe that there are certain things that are actually, you may say, hidden. There are actually certain things which are actually hidden in form of stuff that is not recognizable. Means, for example, if we say that I have a bar of chocolate, it might have a nut in it, it might have an almond in it, but I have to find it out, right? So it means that if it's not written on the outside that an almond is actually present in it, so what is there is a way to actually prove or to justify or to find out the reality of an almond in that chocolate. We first have to actually read the ingredients, right? like it may be written, or we actually have to see the recipe of it if it is mentioned, or the actually you may say that the main ingredients. But if it is not, then what? Then you will actually open it and taste it, right? And then you will actually just assume that, let's say it has an almond. So now what do you see? That actually almond was not written on the bar of chocolate paper. It was not actually made as an picture as a picture on the bar of chocolate. We just had to eat it and assume that, okay, let's say if it is present in there, but we are not actually not seeing it. So I think mathematics actually explains this stuff in this way, that for example, if you do not see something that you or you actually are looking at something, these are two different scenarios, right? But you cannot just entirely deny or reject the reality of the opposite scenario. You just have to take both the scenarios side by side in order to prove or justify the reality of something. Because I am actually explaining this stuff in detail, because I think that sometimes we only think in a very straight way. We do not take the examples of a life or our life experiences in the opposite way as well. It is like we have to actually assume every kind of scenario to prove the reality of something. And how it will be, like it is written that if possible means suppose means you just have to assume something. Like assumption is actually not reality at first. It is actually your just first thought that it could be, it may be that under root 2 is irrational, so that it can be written in the form p over q, where pq belongs to z means integers and q is not equal to 0. Suppose further that p over q is in its lowest form, then under root 2 is equal to p over q and q is not equal to 0. It means that if we suppose that under root 2 can be written equal to p over q, like it is a divisible number, like as we said that if we have to prove that under root 2 is an irrational number, we have to first start by assuming it the opposite of it, like rational number. Then if it is written that under root 2 is equal to p over q and q is not equal to 0, because as we have read the definition above about rational numbers, that they can be divided, but their denominator, that a number that is actually written below the division line, cannot be equal to 0, because something divided by 0 has actually no power or number. PQ are both any numbers which maybe belongs to set of integers z. Then I believe that there is a concept of making equations in mathematics. The concept of making equations in mathematics is that you just have to write down something and make like you just have to write down something and make a kind of a sentence, and you have to actually number it. For example, if you have a kind of a sentence that you write down and then you just number it, then it will be just like you may say that a series, but that series is actually like numbered series, like 1 2 3 4 etc. And equations are like that. Equation by definition also mean that something which is actually equal on both sides. Now what is equal on both sides? Sometimes we say that we talk about the balance in our life. We talk about bad deeds and good deeds, right? That there are certain good deeds and there are certain bad deeds. So if you talk about the fact that if your good deeds are actually equal to your bad deeds, or your bad deeds are actually equal to your good deed, that actually makes this concept to be relative, to be understood in the way that it is okay to actually consider that you might have good deeds equal to your bad deeds, or if you say the other thing as well, that is also true, that bad deeds may be equal to good deeds. But I think that this is the most neutral balance in a life. We should have good deeds always greater than our bad deeds, right? So in this chapter of number systems, we have to actually square both sides. Then we will get 2 is equal to p square over q square, and you know that when you have an under root, we have discussed the definition of a under root. It is actually equal, its power is actually equal to 1 over 2. and then it is equal to p square over q square, or p square is equals to 2q square. Now they are saying that the right hand side of this equation has a factor 2. Its left hand side must have the same factor. Now a prime number can be a factor of a square only if it occurs at least twice in the square. Therefore p square should be of the form 4p square. So that equation 1 takes the form, like you just have to square means you just have to enhance the power twice on both sides, and then you will get 4p square, like 2 times 2 is 4. But if you take p square on the other side, and 2 it will be actually equal to 2q square, and then that is, you may write by cancelling 4 with 2 as 2p square is equals to q square. And in the last equation, 2 is a factor of the left hand side. Like if you see that in mathematics, it is actually 2p square, which is actually the left hand side. Therefore q square should be of the form 4q square. So that equation 3 takes the form 2p square is equals to 4q square, that is p square is equal. It means that you just have to actually cancel out stuff with the same factor. Like you may say that you are going to cut a I think this is actually something like you may actually not have to take something out of it. Factorization is not something like that. Factorization or taking out factors is like that you can just take a piece of apple from a whole apple. That is actually taking out the concept of factorization. Like you can actually consider that 4 has actually 2 twice, like 4 has actually number 2 times, right? You multiply that and then you get 4. Now I believe that these kinds of things are you should be familiar before entering into this you may say that course curriculum or this subject mathematics of this class. You should be well familiar with the fact that we have tables, right? Like 1 table, 2 table, 3 table, etc. And they were like the concept to explain actually that there is only 1, then when 1 is multiplied with 1 it gets 1. But if we get 1 times 2 it is 2. Like 1 is taken as the standard benchmark or the neutral number, and it may be positive, it may be negative. But if you multiply your stuff, like you say that I have 2 chickens, and if I have further 2 chickens, you can also just calculate by 2 multiplied by 2 4, or you can just add 2 chickens plus 2 chickens equals to 4 chickens, right? So this is actually the concept of factorization, that you will see that in the case you have 4 chickens, right? So if you take out 2 and make them a group in a separate way, and then you take out 2 and make them in a separate way, that actually becomes your 4 chickens. But your 4 chickens are actually present in your cage or whatever you have the container. And then I believe that from the I think that from equation 1 and 2 that you have to number it, you can get p is equals to 2p prime. Now you can just name it, you can just cancel out factors and you can just have it. Then from equations 1 and 2, p is equals to 2p prime, and from equations 3 and 4, q is equals to 2q prime. Therefore p over q is equal to 2p prime over 2q prime. This contradicts the hypothesis that p over q is in its lowest form, hence under root 2 is an irrational number. Because if you see that if you are actually cancelling out the factors and you are naming it as q prime and p prime, this slightest line symbol above p or q is actually called prime. In mathematics you may name it as you like it, but I believe that it was actually introduced in the latest stages or in the earlier books of mathematics, because these notations might have a different name in different chapters, and that is okay, that is completely okay. Then we have prove under root 3 is an irrational number. Like on the same terms, you just have to prove under root 3. And why we have actually proven that under root 2 is an irrational number? Because you see that it is just unending, right? You cannot just further divide it, that's it. And prove under root 3 is an irrational number. Suppose, if possible, under root 3 is rational so that it can be written in the form p over q when p q belongs to z and q is not equals to 0. Suppose further that p over q is in its lowest form, then under root 3 is equals to p over q and q is not equal to 0. Squaring this equation, we get 3 is equals to p square over q square, or like in the similar manner you have to make equations and then you have to actually take p or the factor 3 on the other side, and when you follow the similar procedure you actually get the final answer to be as p over q. It means that any number that actually written in under root and it can be proven to be as irrational number, that's correct, but you have to actually follow certain steps. And when you actually have to follow certain steps, you just have to know that there are certain scenarios that actually have to be proved or proven with the help of certain examples, like making equations. And this also contradicts the hypothesis that p over q is in its lowest form. And I believe that every student that is actually or might be listening, or they may be actually signing into the channel in future, I think this is a very important thing for all of us to actually write everything that we want to remember. Mathematics cannot be just I believe that everything should be just practiced after just learning it through this way. Like I'm reading it and then I have to actually write it down and practice it, because I believe that there are certain scenarios that I think like for example, if you write down something you will actually better remember it, right? But in certain things in life we actually have to see that there are lots and lots of stuff that might be in front of us, and it is okay to actually write down some of it as a thumb rule. You can make your own thumb rules but for that you actually have to understand something. Then they say that using the same method we can prove the irrationality of under root 5, under root 7,